Hello and welcome to Root Causes, the PKI and Security podcast where a pair of industry veterans talk about all matters digital certificates and PKI. I'm Tim Callan, Chief Experience Officer at Sectigo, and I'm here with Jason Sirocco, Senior Fellow at Sectigo. So you're picking the topic today,
Tim, here's a fun one.
Okay.
So we're so glad to be in Toronto doing our Toronto sessions, and I wanted to throw a couple fun ones in.
Okay.
I'm going to foreshadow a podcast we're going to do later on PGP. And it's an inside joke between Tim and I because it's a podcast we've been wanting to do for 5 years.
Yes.
And anyway,
all right.
The reason I bring up PGP is because it's quite often utilized for clandestine communications. What I mean by that is not like spy to spy, but somebody who's in a jurisdiction that doesn't allow outbound communication who needs to speak to a journalist in the West.
Got it. Yep.
And PGP has been used for that, right? And amongst other things as well. And the reasons that it is difficult to use will become a lot more clear. The reasons why it's good to use will also become clear as well. I don't think we talk a lot about clandestine communications on this podcast because it's not very enterprisey. However, I want to bring it up because it's cool in its own way, and I want to spark people's ideas on how to utilize a certain kind of encrypted communication for legitimate uses.
Okay.
But by bringing up first potential clandestine usage.
Okay.
What if I were to tell you, Tim, that there's a not very well known out of a certain kind of community IoT protocol that can be used for short text messaging across fairly good distances, like upwards of 50 to 100 kilometers in some ideal scenarios.
Okay.
So if you and I right now, when you and I got, messaged each other this morning, we did it with a smartphone.
Yeah. Yep.
Right? And we could have used Apple's iMessage, we could have used Signal, we could have used WeChat or somebody else's chat. But ultimately over a phone and ultimately over somebody's cellular network or Wi-Fi.
Yep.
Great. And a lot of these things claim end-to-end encryption. A lot of people say not really and whatever, right? And what the heck, maybe that could be subpoenaed in some jurisdiction.
Sure.
So therefore, if you're using that kind of off-the-shelf technology, would you really do the most clandestine communication possible over it?
Well, what's your other choice?
I'm going to tell you one.
Okay.
And this is the point. LoRA. So the LoRa protocol.
Okay.
And we'll get into what that is in a moment. But what it is meant for is IoT devices being able to communicate over LoRa protocol to a server that's listening for telemetry.
Okay.
Or perhaps, it's a pump that will receive a command from some central dispatch, and it will receive it via LoRa.
Okay.
Some of the big advantages to it are it's, in noisy environments with a lot of 2.4 gigahertz traffic, and you don't want to do Wi-Fi. Sometimes, if reliability and uptime and longer distances are your thing, or perhaps you have operations in areas that don't have cellular networks or easy to put Wi-Fi, LoRa can be your thing.
Okay.
Think about all those IoT scenarios, Tim. Think about a pump that's sitting in an oil field in North Dakota or Alberta, Canada. And that pump is nowhere near a Wi-Fi.
Sure.
Nowhere near anything of traditional off-the-shelf technology. But you need it to receive a command, and you really need it to receive it when that command comes. So it needs to be reliable, and it needs to cover a long, long distance, because sometimes these pumps are 20, 30, 40, 100 kilometers spread apart.
Okay.
All right. The LoRa protocol actually has a key exchange mechanism within it. So therefore, whenever a communication session is set up, there actually is a Diffie-Hellman key exchange going on.
Okay.
And all data, once the session is set up, is encrypted AES 256.
Okay.
All right. In fact, during the key exchange, I believe the exchange keys are encrypted AES 128, 124. Don't quote me. So here is the point. There are now experimenters. Meshtastic is one of the projects that's out there. We'll call them out. Mm-hmm. And they're actually setting up what are the equivalent of home-brewed cell phones.
Okay.
So that you and I could text message each other in areas that have no cellular at all. And we could be 50, let's say 30 kilometers apart.
And this is a point-to-point communication?
Point-to-point
device to your
encrypted
device.
communication.
Just over the airwaves.
Correct. Now, there are parts of this protocol that allow for group communication. So you can have more than 3 people.
Okay.
But think of this like text messaging via the equivalent of what you and I would have called a walkie-talkie.
Well, I was just going to say, right, it's like walkie-talkies.
It's a walkie-talkie with end-to-end encryption.
Okay.
For text messaging.
Wow.
So if you and I were 1940 spies, we would have knifed each other for this technology.
So does this is this like, are people using this in IoT networks today?
Yes.
Is this okay? So this
widely
is proven.
Widely used.
This
proven.
is okay. Fascinating.
So take what was originally conceptualized as I need to get a command to a pump in the field. Right. And I do not want to use cellular. I don't want to use Wi-Fi. I want to use a reliable IoT, dedicated IoT protocol.
Good old-fashioned radio transmissions. Yep.
And I do not want this communication to be messed with, so I'm going to encrypt it. Mm-hmm. It's more for the integrity than the clandestine nature of the message. Right, because you're in this
very noisy environment, and they're far away from each other, and you need to make sure that the other device understood what you're saying accurately.
Right. But what happens if you made a walkie-talkie?
Sure.
And you and I can, you put a little keyboard, a good old-fashioned BlackBerry-style keyboard.
Nobody can tell what we're saying.
So that's happening now. And that project, there's several projects that are out there. There's nothing proprietary about this, but there is Meshtastic is a project out there for those of you who want to do an internet search or are curious about these things. Those things are out there. You can buy the stuff off of Amazon right now.
So I get it at a high level. How are people imagining this really being used? So is it like I get myself one of these devices and now I can communicate with, let's say, my fellow demonstrators in the oppressed regime, and we all get these devices and we text to each other, and we know that we're not pinned to a place. Nobody can track it back to something like an IP address. Nobody can read what it is.
That's why I brought up PGP at the beginning of the podcast.
Yeah.
You just brought it full circle. You got it, because it's used for could be used for the same purposes.
Wow. Okay. Now, that isn't really real today. That is just sort of in science project land. Is that right?
I think people are holding that in their hand right now.
Okay.
And I would say this as well. There are also LoRa gateways and LoRa repeaters.
Okay.
Which means
great.
You could be a dissident.
We don't have to be,
You could be a dissident and in a clandestine way have your message repeated to some other jurisdiction, potentially.
Yeah.
Or to some place where the message can get out.
Right. So that can give you distance for starters, right? You get out of this range problem. And number 2, you also, I think, can get away from the location problem, because the problem with something that's based on direct transmission is, at least to some degree, it pins you down to a physical location.
Exactly.
But if it's hitting a repeater, if it's hitting a gateway, and it's popping out 2,000 miles away, then nobody's ever tracking that back to where I am.
For sure. I definitely think for people who think about these things deeply, the ability to sense a transmission is always there, right? So in other words, I guarantee people who are the countermeasures to this are there in the sense that they won't be able to understand the message potentially,
Right.
but they can detect signaling.
Right.
Right. They can detect the RF.
So if you were prepared to say that I'm going to conclude that all signaling is always bad, then that's legitimate. But there's lots of electromagnetic transmissions that go on all the time. I could easily see where it could, pragmatically speaking, being very, very hard to say this unintelligible encrypted signal is the one I care about, as opposed to other unintelligible encrypted signals that are just operating IoT devices, let's say.
That's true, unless it's on very specific frequencies that only this uses,
Yeah.
and so therefore it becomes less of a secret that you're doing it. So pluses and minuses. On the other hand, my goodness, if nobody's suspecting you're using it, then my goodness, it becomes an interesting form of communication. And not all of this is for cloak and dagger stuff.
Right.
If I'm a ham radio operator, I might want to have an alternate means to send my APRS position to somebody else. Perfect.
Yep.
There's all sorts of legit reasons why people might want to play with this, and they are playing with it, Tim.
Wow. Okay. That's fascinating.
Yeah, cool stuff.
All right. Thank you, Jay.
Thank you, Tim.
This has been Root Causes.